Welcome back, guys. Welcome back to this session. So today we'll be understanding the pre-order traversal. Previously, we understood the in-order traversal. So here, now we'll be understanding the pre-order traversal in more programmatic manner. First, we'll be understanding that how recursion works. So pre-order, pre-order. So what we noticed in pre-order that general tree is like this. There is the root, and in the section there is left tree, that is left tree, and in the right section there is the right tree. So that was the general tree structure we all know, and this general structure is called in order. In what if we just visit the tree in this fashion, that first left, then root, and then right, we call it in order. And when we just bring this root in the previous, it becomes pre-order. So the pre-order traversal becomes root, because root comes at the forward, so it becomes root, then left, and then right. So the pre-order traversal is root, then left, and then right. So it's very simple program if I just tell you in terms of recursion. So first we try to find a base case. Let's try to understand this problem with the help of example. Let's remove it. Okay, we can keep it here. Just keep it here, and we don't need to it also. This is also small things, so keeping it here. So okay, we just understood this section. Now we'll be creating a tree. So let's create a tree, and we'll be understanding with this example. So we'll be taking the tree from here, that 50, 30, 70. First we insert 50, 50, then 30, then 70, and then we insert 20, 40, 20, 40, 60, and 100. So this is the tree right now we have. So in pre-order, we first visit the root. That means when we come, this is the root pointer. Root pointer points to that node, and this node is called as the root pointer. That is called as the root pointer. So how our program works? First, we'll be understanding the stack architecture. It's like first it stops, it first processes the root. Once the root is processed, it then comes to the left section. After root, it processes to left. After root, it generally processes left, and after left is done, it processes right. So first the root will process this one, root, and then it will process the left section. So it will move towards the left part, and then again it will process the root. It will process the root, and again it will come here. It will again process the root, and then it will again move the left section. Once it encounters null, when it encounters null, this program will stop and it will return. Now this program will back return into from where it came. So it will back return into the root node again, and this is the root node. So here this is the root node, and again it will check for the first it will just process the root, then this left one, and then it will process the right section. It will again encounter null and it will return. So once this root has been done, this root, this parent root, and this left side, it will now come to this section, and it will again visit the same section like this. So if we try to understand it in terms of stack, so it will work like this. If there is a stack, if there is a stack, so it will work like this. First it will process the root. First it will process the root. I mean, let's write the code, and then we'll be understanding that how it internally works. So the code is like this. First we process the base case. So the base case goes as if public void pre-order. So this is the function that we write, and it works using recursion. So we pass the data type of binary tree node, and we pass the main root, and then we start writing the code. So we first check if now we stop here, this is the stopping condition, that null is the stopping condition. So we write like this: if root not equals to null. If root not equals to null, then we'll be keep running the program. So now we'll be writing the program for this one. First, what we process every time, we process the root section. So we'll be writing for that section, that will be printing. We'll be just processing that element. First, we always write the system. So let's print system dot out, because this is traversal. That means we will be visiting the element. So system dot out dot println root.data. So we process the data portion. Once we have processed the data portion, now we have to move towards the left side. That means once we have written these elements, now we have to move towards the left section, that section. So now we'll be writing for that, and this is just not this. Now it will again happen, now again happen, it will again happen. So this is the entire for loop recursion. It will keep working from here again until it encounters null. That means this condition it is stop, and it will stop only in that section. For that we'll be using the preorder. So preorder root.left, because that is the rule that we have to process root.left, and then we'll be processing preorder root.right. So this is the entire criteria, and implementation of this code will work for us, and this will provide as a result in order traversal. So this is how it will work, and how it actually works is, whenever first it encounters, okay, we'll be taking this program from here. Okay, so we'll be trying to understand with respect to the entire program. Okay, we didn't got. Okay, just keep it here. We try to understand with respect to respect here. That first we'll have a type of stack like this. This it, and we know the. Okay, let's leave all and. So as the border says in order. So right now we are working with preorder, and we all know that preorder. First there will be a root, and then there will be left side, and then there will be right side. So how it works, that if we have a stack, so it first prints this element root. After it prints, after it encounters the root element, it comes to left section, and again when it encounters the same prefix function, it encounters the prefix function, again it creates a new loop, a new stack for it, and again it works, and again it prints the root, it again prints the root in this section, and again it encounters the function prefix, and again it moves to the next one, and again same things keeps happening until the condition comes when the prefix, when this prefix node it becomes null. So one time it comes when it encounters that the prefix function gets the value null, it gets the value null, and once it gets the value it stops. Now it keeps returning back, back, and once it has returned back, now after the prefix of this, now it start processing the right section. So it processes the right section like this. Now it enters the right section, and again it's keep processing the right elements. So this way it keeps processing inside this stack. This is very easy to understand and not important for us. The main things we have to focus is the programming. So let's implement the program, and first let's write this how we could get the elements with the help of preorder. So if we just utilize the preorder here, so the order in which we will be getting the elements will be, first what we have to process a root. So first we'll be processing this 50, we will be getting 50, and then we have to process the left element. So we'll be coming in that section, the left section, 30. So when we get 30, again we have to process the root element. So we'll be getting the 30. Wall time, whenever we shift, we have to notice the root element here, 30. Again, we traverse here the left section. Again, we traverse in the left section and we get 20. So we'll be printing the 20. And once we got the 20, there is no elements, it encounters null, so we'll return. Now we'll be processing the left side that we have already processed 20. We'll be processing the right side 40, so we'll print 40. Now after printing 40, we'll be noticing this the right side. As per the system, left root, root left right. So now right, again in this right, this is also this one is the root. So we process 70. After 70 there is left portion that we have to provide, so 60 and then 100. So this is the processing. Let's see if it works in the code or not. So we'll be writing the code for PreOrder. Okay, so the code for PreOrder has already been written. Now we'll be just checking it. So instead of in order, we'll be just moving it into PreOrder. PreOrder traversal 3.root in order PreOrder. Okay, so let's again compile the file. Java compile and Java. So PreOrder traversal, as you can see, first we have processed the element 50, then we have processed the element 30, and then we have processed 20, 40, 70, 60, 100. So our entire traversal matches with what I just saw you. If you just observe in the copy, you can see that entire traversal is same: 50, 30, 20, 40, 70, 60, 100. So this is how PreOrder traversal works. So in next session we'll be understanding the post order. Okay, then meeting in the next session.